Greetings all. We're going to look at factoring polynomials. We're going to use a table to help us out. So our goal is to try and break a polynomial down into linear terms. They can't all be fully reduced. For our purposes, we'll have linear and at most one quadratic with our polynomials. You might find it differently. However, no matter what kind of polynomial or anything you're factoring, the first step is always going to be to look for that GCF, greatest common factor. And that doesn't matter if you're using a table, if you're using your basic math facts, whatever you're doing. The first step is GCF. For our purposes, we're going to look for zeros with a table. So we're going to type that into the calculator. We're going to look for y values of 0. Now, sometimes you won't directly see a y value of 0, so we'll have to apply our rational root theorem and the intermediate value theorem. Like, oh, hey, look, it goes from positive to negative. One of these fractions, based on the rational root theorem, is going to work. Or it just might not have a rational root there. Once we find all of our possible zeros that we can with the table, we're going to do synthetic division over and over and over again. And once it's down to a quadratic, before we begin anything else, we're going to look at the discriminant. So if you start with a quadratic, start with the discriminant. It would be terrible to go through the entire process of typing in the calculator, going through all the possible integer roots, then looking at all the different rational roots, and just to realize, oh, wait, if I would have done the discriminant, I would have known it does not factor. Okay, so let's just jump into one. We have a quadratic here. First step, GCF, let's see, 6, 28, 16. Those are definitely all even, so I can factor out a 2. Actually, let me do this so it's a little bit more legible. So I'm going to factor out a 2 here. That's going to be 2, and then that's going to be 3x squared minus 14x plus 8. Okay, I'm looking 3 and 14, nothing in common, so we're done with that. That is the GCF there. But again, GCF is first, but once we have a quadratic, check our discriminant. So let's just check it out here. It's going to be b squared minus 4ac. So that's going to be, b is negative 14 squared minus 4 times 3 times 8. So let's just check and see what that is. Grab my calculator real quick. I have a terrible memory, so it's negative 14 squared minus 4a is 3, c is 8. And that gives me 100. Well, we know if our discriminant is a positive perfect square, it can in fact be factored. We'll have rational roots. So if we check, if you don't happen to know that 100 is a perfect square, you can always check square root of 100, and yeah, that's 10. Not a decimal, nothing with a radical on it. It's a nice integer number, or integer or rational, either way, would still be factorable. So we're good. It can factor. Let's do it. So all this was to see factorable. And yes, it is. Okay. So now that we know it's factorable, we factor out the GCF. Let's check out our potential zeros. So with the rational root theorem, we know they're going to be between a negative 8 and a positive 8. And all the possibilities would be, we'll get there if we need to. Let's just go for the table. Let's see what it looks like, and then we'll go from there. 3x squared, so table 3x squared minus 14x plus 8. Starting at, again, the smallest possible rational root is negative 8 by the rational root theorem. I'm going to keep my step at 1. I would highly advise changing it to 1 if it's not already on your device. And just click OK. we're looking in the y column for a value of 0. Okay, so between 0 and 1, I have a root. Um, let's go down and see if we have anything that's, oh, look, there it is. We have an integer of 0, an integer x value of 4 gives us a y value of 0. So one of my roots is 4. So I know 4 is one of the x values. Okay. Now, the other one has to be between 0 and 1. So it's some sort of positive fraction. We don't need to in this particular case because we do have an integer. But let's look and see what we would do if we didn't. We need the factors of 8. 1, 2, 4, and 8. That's all the different combinations we can get. And the factors of our leading coefficient, 3, 1, and 3. So in order for it to be between 0 and 1, I know I can't use these guys, okay? That's not going to happen. I could do 4 over 3. No, that's bigger than 1. 4 over 1 is definitely bigger than 1. 8 over 3, nope. So it's either going to be 2/3 or 1/3, because 2 over 1 and 1 over 1 are both rational numbers, integer numbers. So the other number here is either going to be 1/3 or 2/3. And it's going to be positive because we can see right here it's between 0 and 1, positive. In this case, though, we got this guy. It's a quadratic. We've got two roots. Once we do the synthetic division, it's going to give us the other one. So let's just do the thing. So I'm plugging in 4 into the synthetic division. Write down all of my coefficients. Use the smaller numbers that we have factored out here. 3, -14, and 8. Bring down my first number. Multiply, combine, multiply. Again, if you don't get a 0 here, you screwed up. Go back and try again. So I can see it's going to be the 2/3. 3x minus 2 equals 0 gives us 2/3. But we're factoring, so we don't even care about the 0. If you needed to solve a polynomial, you could use the table the same way. But we don't. We're factoring. So 3x minus 2. That's one of my factors. Now I'm going to check for some things here. GCF. No. Is my x positive? Yes. I would advise to factor out a negative if you had a negative x here. It'll just make your life a lot easier. Okay. In this case, though, no, it's positive. There's no GCF. Done. Then we're going to use this, x equals 4. Just do a little bit of back solving. Make that equal 0. X minus 4 is equal to 0. So that means x minus 4 is my other factor. And I'm having trouble drawing a parenthesis here. So x minus 4. So this is my factored polynomial. Oh, wait a minute. Don't forget about the GCF. Okay. That's why we have to do that first. If you do synthetic division, it will kill your GCF. It's gone. So make sure you factor it out first, and then don't forget to put it back at the end. If you do that, you'll be good to go. No worries. If you don't do that, this 2 would have just disappeared completely and totally. Okay? All right. So this one's factored. From there, who knows? You might be done. You might have to do it 3 more times for multiplying some polynomials together and simplifying them. I don't know. Whatever you're doing with it, this is how you factor. Let's look at this. I can immediately tell there's no GCF because I have a 1 right here. So I'm just going to go for the factors. 18x squared. Let's go back to the table. Clear that out. 18. Oh, wait. What should we do first? Check the discriminant. And I'm pretty sure I messed up here because that's going to give me a negative discriminant. Am I even recording? Okay, good, I'm recording. Let me go back for a second, guys. I think that's supposed to be -4. Yeah, it's supposed to be -4. Sorry. Now let's try that one. Okay, this one should work out. Discriminant. B squared minus 4ac. Yeah, you can read my writing. If not, listen better. B squared minus 4ac. Okay, 1 squared minus 4a. Doesn't help with the lag. C. And before I even wrote it down, I knew that was a positive, and that was a positive. There's no way that would be a positive discriminant. So I was like, okay, I messed up somewhere, and that's how I knew to go back and look. So this should be a perfect square unless I made some arithmetic errors. Get out of here. 1 squared minus 4 a c. 289. Hmm. Is that a perfect square? Answer button there, and oh yeah, it's 17. So yes, it's a perfect square. We're good. Let's factor it. So again, this is just checking. Can we factor it? Yes. Yes, we can. Do it. So go to the table, clear that out, type it in. Now to 0. There we go. 18x squared plus x minus 4. Make sure you use the minus button and not the negative button, guys. It matters. It matters a lot. So I'm going to hit enter there. Rational root theorem tells me negative 4 is my smallest possible rational value. So I need to look between negative 4 and positive 4. Again, what I'm looking for at first is just the smallest and biggest. So plus or minus 8 is all my rational roots are going to be between there. Plus or minus 4, all my rational roots are going to be between there. Let's see. So I'm looking. Okay. Oh, okay, so somewhere between negative 1 and 0. Let's see if we have a nice one. I don't. Oh, no. Uh-oh, I might have actually screwed up again. I meant to not have a nice one, but I thought I had two. Okay, I know what happened. So both of my rational roots are going to be between 0 and 1. Um, I have one. I know I have another one. So I know it's got some because this checked out. So they got to be between negative 4 and 4. And the only sign change is between negative 1 and 0. So both of my roots have to be in there. Thought I made it positive, but we'll see what happens. Let's just wing it, guys. Again, potential roots. 1, 2, 4. 1, 2, 3, 6, 9, 18. That's a lot. So the factors of this guy, factors of that guy, that's what we're looking at. Okay. So if I do 1, that's going to give me a rational number. That ain't happening. If I do 2, let's see, it's a negative. It's between negative 1 and 0, so it's going to be negative numbers. So I could do negative a half. But then 2 and 4 divided by 2, that's out, because those would be, again, integers. 2 over 3, so negative 2/3 is possibility. 2/6, that's negative a third. We got a lot. Um, Let me write that a little bit better because lag. So 2 over 3. 2 over 6 is 1 over 3. So negative 1/3. 2 over 9. 2 over 18. That's 1/9. Okay. Now let's look at the 4. So all of these are also, that's a lot to check. Also between 0 and -1. All of those are between 0 and -1. Okay. 4 over 3 is not. 4 over 6 is, but it's 2/3. We already got it. 4 over 9, that's a new one. So -4/9. 4 over 18, that's 2 over 9. So we already got that. Okay. One of these will, well, two of these will work. So that's 1, 2, 3, 4, 5, 6 things we need to check. So I'm going to go back to the table and we could actually go by ninths for the step, I guess. We know it's going to be between -1 and 0, so I'm going to start there. I'm going to just go over ask. Here's what I would probably usually do. Ask him. Let's try -1/2. Let's get lucky. We did! So you could check these as you go if you really wanted to. So -1/2 will work. We could stop there and do synthetic division. That's what I would suggest. Or you could test all these and see which one the other answer is going to be. Your choice. So let's see. I'll just do synthetic division. So we combine those and we get the result of 0. Yay, no screwing up. Again, check for a GCF. That's 18x minus 8. That has a GCF of 2. Is it 2? Yeah, 2. 9x minus 4. Okay, so this 4/9 is going to be the other one. Let's be positive. Hang on a second. Okay, maybe I'm blind. Let me go back and look at the table. Don't hit that button. -4 to 4, but I'm going to go back to auto. I just want to check something real quick. Oh, wow. Okay. So there's one negative number here, so it changed from negative to from positive negative here and then negative positive here. I just kind of jumped over that. So one's between -1 and 0, the other one's between 0 and 1. And yeah, we factored it, we found that. So we could have tested all these and just kind of been SOL. Good thing we didn't. Um, we knew one of them was negative though. So once you get one of your zeros, just do the synthetic division to make your life a lot easier. Now technically this is going to be x minus a -1/2, so plus a half. We don't want fractions. We do not. The good news is, though, we have this 2 right here. So you know what we're going to do? We're going to distribute it to this guy that has a fraction in it. That's going to be 9x minus 4, 2x plus 1. Now you could have just back solved just fine. We're going to do that step here. Just so you can see, you'll get the same result. X is a -1/2. We clear the fraction first. 2x, add 1 equals 0. 2x plus 1, same result. Okay? And if we look, we should have an 18 when we multiply the first two numbers together. 9 times 2 is 18. Yay. This is factored. We're done. Move along. So I figured we might as well throw in one of these giant 50-degree polynomials just to see that, oh yeah, same process will work. So it's not a quadratic. There's no discriminant test. I'm looking through here. Oh, I do have a 2. Let me just copy paste that. And I'm going to factor up the 2. Divide everybody by 2 in here. Hopefully I don't mess up anything in my head. And we're going to use these nice smaller numbers to work with. So instead of between -64 and 64, we only have to look between -32 and +32 for some zeros. Yay. So type that in. Table, x to the 5th. plus 6x to the fourth plus 16x to the third plus 32x squared and 48x plus 32. Hit that. Again, rational root theorem tells us negative 32 is the smallest possible rational root there. Go auto step of 1, check it out. That's a huge freaking number. We really don't care what it is. We're going to go down till we change signs or find, hey, look, 0. Let me go back. Negative 2. Write it down. And I'm going to write down every one of them that I see to save myself more work. Wow, is that the only one I got? That's just kind of rude. Okay, negative 2 it is. So let's go with negative 2. 1, 6, 16, 32, 48, 32. Now, because it's a negative 2, this is going to be like negative 2 to the fourth power or something. Or negative 2 to the third power, maybe. Or not negative 2 to the third power. X plus 2 to the third power. We'll see, we'll see. Just do the synthetic division here. And yay, we get a 0. So, because of, how this would work, we could check this new polynomial and see what we get. But since we didn't see anything else in here, and we still have 3 more zeros, 4 more zeros, because it's a fourth degree still, it's a fourth degree. So we still have 4 more zeros. I know by design that at most 1 is quadratic, so I got 2 more negative 2's in here. Watch. We're gonna do negative 2. I'm gonna pretend I don't know that. Let's look and see what happens. If we don't know that, that's gonna be reduce the degree by 1. So x to the fourth, go back to the table. We can do the thing. X to the fourth plus, it's not a plus sign, 4x to the third. I'm just using these coefficients, reducing the degree by 1, plus 8x squared, plus 16x, plus 16, and negative 2 is going to be our solution, the only one we see. It has to be between negative 16 and positive 16, so let's start there. And we're again going to see a negative 2 works and nothing else. Negative 2 works, and nothing else. Again, it's the way these are designed, they're going to have at least 3 rational roots. This guy has a 1 right here, so there's no fractions. It's got to be an integer. And the only integer we found was negative 2, so that's going to happen 3 times, which is perfectly fine. So I'm going to bring that down, multiply, combine, multiply, combine, multiply, combine, multiply, combine, and we get a 0. Now, I could do the same process again, but I'm not going to. It's a negative 2, y'all. Bring down, multiply, combine, multiply, combine, multiply, combine. And we got ourselves a 0. So now this is down to quadratic. I have 3 coefficients basically, so x squared, x, and constant. Let's write it down and check it out. X squared, no x's, so b is 0, plus 4. Now you should know right now that that doesn't have a real solution, but if you don't, We can check the discriminant. 0 squared minus 4ac. And that's 0 minus something. That's negative 16. That ain't happening. That's not factorable. Okay? So this quadratic right here is not factorable. We know that because our discriminant is not a perfect square. 16 is, but it's a negative 16. So that's going to have a nice little I on it, right? Not factorable. So this will be our first factor, or one of our factors. Doesn't multiplication is commutative. You can multiply it in any order you want to. But I got this guy. Is x squared positive? Yeah, that's positive. We're good. Is there a GCF? Nah, dude, that's got a 1. Okay, so that is my first factor. Then I got x equals negative 2 3 times. So I'm going to do x plus 2, a little bit of back solving there, to the third power, because it's 3 freaking times, and we're done. Okay, easy as that. And if you forget that, you fail. GCF is 2. Okay, the first step is to check for GCF. And after you write out your answer, make sure that you put your GCF. Excuse me. Yeah, that's it. So this will work whether it's quadratic or beyond. Once you have a quadratic, though, check if it's factorable. Save yourself some time. Check. Use your table. Look for y values of 0. If you don't find any, look for sign changes. When you see the sign change, look at the coefficient or the leading coefficient and the constant. That'll tell you your possible rational roots. And just do the thing. All right. See ya.